Amigos de Data Evolution, nos encontramos aquí en Utah en el evento anual de Centros de Datos y tengo el placer de estar con Phil Lawson. Thank you, Phil. Phil es el Chief Innovation Officer de Aligned Data Centers. You are the Aligned Data Centers Chief Innovation Officer.
I am.
What's
yes.
the purpose of your role in innovation, especially in these days?
Well, innovation is everything. Invention is fantastic. Invention takes too long. If you look at the history of society, of humanity, we've always built on the technology of before. And right now we're seeing a huge technology upturn, faster adoption of new technology than we've ever seen in the past. So innovation is everything. So my role is to I have to think about what our clients might want to do in 2 or 3 years.
Which is a challenge right now, right?
Challenge, yes, because if you think if we start designing a data center today, it'll take us 12 to 16 months to build it. So what we design for today, the client may have an entirely different use case in that time frame. So we need to build it so it's adaptable, it's flexible, and it meets their requirements, not only for that workload, but also they'll do a change in maybe 2 years, hopefully longer, but it's getting shorter and shorter. So we need to adapt and adapt and adapt.
And how do we adapt to those changes that we have right now?
That's
we spend some time talking in this panel about that, right?
So the two primary, so the workloads are changing. Right now, AI is fundamentally creating large language models. We're really quickly getting to the inference stage. So those models are being used for business operations inside enterprises, inside healthcare. So the optimal way to use those models, those inference, is to place it within the enterprise business cloud. So if you think about it's fascinating how an AI engine operates, but it understands context, it understands how to respond to a question, but it doesn't have any data. So it has to sit within a set of data, so in a cloud architecture, to present the answer. And the closer it is to that data set, the faster the answer. And we're very impatient as a species. We want that answer straight away. So we'll see a transition from those inference engines and cloud services, cloud data centers, to be both cloud and inference everywhere. Different sizes, different shapes. And with that, the hardware changes. So we're moving from a CPU-based technology, which is very predictable, load cycle, power, heat production. GPUs are very unpredictable. They require much more power. The load profile is more spiky, and the heat generated is far greater. So we need to mitigate the heat, remove the heat. So we need a blend of liquid and air cooling in the same space, or just a lot of liquid and a lot of air. So how we design and how we think is we need it to be entirely adaptable for whatever's coming. And also the rack's getting larger and heavier. And so there's the whole densification process there. The load bearing is greater on the floor. The rolling weight is different, moving them in and out. I joke about this. We've optimized for cloud data centers, and it's pretty easy. You just stamp them out. Now it's really interesting. It's every deal that we look at, every business opportunity, it's an engineering challenge, just for what they're asking for and what we think they're going to need in the future.
It is an engineering challenge right now that we're living. And what's your point of view about the trends, the main trends that we see? We have seen a lot of innovation about energy, which is BESS, you know BESS,
oh, yes. Yep.
And liquid cooling.
Yep.
Do you see the future coming for instance, liquid cooling in immersion cooling, or direct-to-chip, or
I think
rear door?
Immersion's interesting. Well, rear door, we don't need to do rear door because of the way we do our cooling. Rear door is a stopgap to try and help less efficient air cooling systems and less efficient liquid cooling systems. Immersion is a ways away because of the chemicals that are used. They're PFAS, they're forever chemicals. Mm-hmm. So there's regulations about how they can be used, and we personally don't want to use them.
Nation is more popular, right?
Exactly, yeah. Immersion, yeah. So if you're doing data mining, immersion's fine. That can be somewhere else. But when it's in an enterprise class or a hyperscale class or an AI class data center, it's a very different thing. So liquid to the chip is ideal right now. Densities are getting higher, but the standards are in flux. They're being developed as we go along. So if you talk to OCP, who developed the liquid rack, OCP OVR3. If you talk to them, if you talk to NVIDIA, if you talk to Grok, if you talk to AMD, everyone has a different, and even the hyperscalers, everyone has a slightly different view of the size of the pipes, the flow rates, the return temperatures. It'll normalize over time. We're just in that cycle where everyone's trying to squeeze the most profitability out of what they're building. But invariably, everyone will look at everybody else and we'll normalize. So it'll be a de facto standard instead of someone stamping a standard that people are going to fight against.
Yeah, and one of the challenges that we have found as well is the megawatts per rack, right? Now, yes. Not kilowatts. Now 1 megawatt. Yes. Quién spend some time talking about the megs per rack.
Yes.
Do you think you see that coming within the next couple of years?
Oh yes, absolutely.
For hyperscalers only?
No. I think companies. Well, Quién, the company Quién works for Lambda. They're becoming a hyperscaler. We call them the neo cloud, but they're really a hyperscaler emerging. So those will be the clients that will use it, and the hyperscalers first. Absolutely, because they have deep partnerships with NVIDIA, who are producing the silicon or licensing the silicon. So they'll be first adopters for that product. But those megawatt racks, it's not just one physical cabinet, because if you look at OCP's architecture, if you're familiar with that, where it disaggregates the technology, there won't be enough space to put the battery shelf and the power shelf. So that's going to go in an adjacent cabinet, which will be bolted to the process cabinet. And those power supplies will be liquid cooled as well. So now you're looking at 2 rack spaces, 2 21-inch rack spaces, and almost 4 feet deep. I'm doing it in I should switch to metric for you, I apologize. But yeah, so these are much physically bigger entities. They require much more power, multiple power leads coming in, and we're looking at potentially switching over to DC power instead of AC power, because that's just more efficient. But again, upstream, that's a whole different set of technologies that we have to consider. So we design our electrical rooms on skids so that we could potentially switch those out, those AC power, to higher voltage AC power or a blend of AC and DC power, or whatever the client wants going forward. So again, flexibility, adaptability, that's everything.
Adoption and adoption as well at the same time, right?
Exactly.
Last but not least, thank you, Phil, for your time. Retrofit. Some of the concerns that we have found in some data centers is the investment that they already have in a data center, maybe the capex of maybe that was done in 2021, 2020. What is your recommendation for the data centers that they invested 3-4 years ago and they have to reevaluate the concept of a data center?
That is a challenge. We designed from the ground up. So most of those data centers will have a raised floor.
Brownfield.
Yes, yeah. So it really depends. It depends on if that it depends how long the data center's been going, I guess. I mean, you can retrofit them. There are technologies where you can have airside cooling coils. So you basically have a CDU, air-based CDU, adjacent to the rack. So AWS recently announced they're doing that. There's a whole webcast on there. So that's a way of doing it. And then you have to spread out your load. I mean, the problem with raised floor tile is it's loading. So if you then start bringing these much heavier cabinets, the rolling weight will crack the cabinets. Just having them situated could crack them. So there's a place for those legacy data centers, and I use that term pejoratively on purpose. But there's a place for them. They won't go away. But still, cloud is a huge market still. We're still deploying lots and lots of cloud. So the data center business isn't pivoting to AI. AI is just another stream of product. And what we're trying to do is anticipate the bifurcation so that we can optimize our supply chain, our delivery, all of those things to deliver the right product that can be flexible.
Right. Would you build a data center for AI with raised floor?
No, we wouldn't. We don't use raised floor at all. We don't need to. Raised floor you only need raised floor for plenums, underfloor plenums. A lot of people can do the piping underneath. And that initially there was a lot of people wanted to move the pipes underneath for the liquid cooling, but in actuality they'd much rather have them overhead because you can see them, because maintenance is everything. So
that's a great advice.
Yeah.
And you can keep it for all the audience. Yeah. Y es un buen consejo para no usar piso falso de parte de Phil. Any recommendation? Last question for you. Any recommendation for people for training? One of the challenges that we have is the culture. Yeah. How do we adapt to the AI environment? Yeah. What is your recommendation for leadership with people?
Well, I think the whole of the data center industry, we don't have enough of skilled tradespeople anyway. So regardless of the operations team, so I'm not even talking about using AI as a business tool. I'm just talking about the structure of building these buildings. We need so many more electricians, mechanical engineers, fitters, welders, sheetrock people, people who can know how to form concrete. A lot of that, we seem to have lost that skill set. So we do a lot of work with various organizations, like this one here, Nomad Futurist. We spend a lot of time going into high schools and encouraging kids that maybe they're not going to go to college and showing them that this is an alternative educational path or career path that they hadn't even thought about. Because if you come out of college, if you go to college, you'll come out at a certain price that you'll be looking at. You have to pay for your school debts, certainly in the US. But if you were train in a trade school, you immediately come out and earning significant money in your pocket, because there's so much business to be had in just not only data centers, but industries coming back to the Americas, and we need so many more skilled people to make that happen.
That's true. Well, este es el punto de vista de Phil Lawson, que es el Chief Innovation Officer de Align Data Centers. Phil, thank you very much for your time.
Thank you.